Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking, a mechanical engineer is considering building automated materials handling equipment for a production line. On the one hand, the equipment would substantially reduce the manual labor currently required to move items from one part of the production process to the next. On the other hand, the equipment would consume energy, require insurance, and need periodic maintenance. Alternative 1 says continue to use the current method. Yearly labor costs are 9,200. And alternative 2 says build automated materials handling equipment with an expected service life of 10 years. First cost is 15,000. Labor cost is 3,300 per year. Power is 400 per year. And maintenance is 2,400 per year. Taxes and insurance are $300 per year. If the MARR is 9%, which alternative is better? Use a present worth comparison. Now let's go ahead and continue here. Okay, let's continue here. So first use the alternative 1 method, that's present worth 1, that's equivalent to, we have yearly labor cost, that's 9,200. So cost, it's a cost, so I put negative 9,200 times P over A. This is 9%, it's given 9%, so I put 9, and it's for 10 years, so I put 10 right here. And if you calculate, you will get negative 9,200 times 6.4176, and that will give us negative 59,041.92, and that is PW1. Now let's do the alternate. This is alternative 1. Now let's go ahead and do the alternative 2. Alternative 2. Now here we are going to again find out the present worth factor, but for this one we had to include everything because everything is given. So let's go ahead and do one by one. Present worth factor 2. Here we have first cost, that's 15,000, so that's a cost negative 15,000, and after that everything is a cost 3,300 per year, negative 3,300 per year. If they mentioned per year, we had to use this one, P over A 9, 10, because 9 is percentage and 10 years. So P over A 9%, 10 years, and for everything we had to use the same thing, minus 400 P over A 9%, 10 years, and then minus 2,400 P over A 9% for 10 years, and then 300 P over A 9% for 10 years. And if you add them together, you will get first we have a negative 15,000 minus, and if you add them together, that's 6,400 P over A 9% for 10 years, and minus 15,000 minus 6,400, 6.4176, and that gives us negative 56,072.64, and that's present worth factor 2. Now let's calculate the servings. Servings is equal to 59,041.92 minus 56,072.64, and that gives us 2,969.44, and that's it. That's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching, and if you're trying to learn engineering economics, there are a bunch of videos in my playlist. I hope you guys watch it too. Don't forget to subscribe. See you next time.